Okay. Objective 3. What is it?
Graphing linear functions.
Graphing linear functions. Okay, well, the good news is I'm not going to make you do any graphing today yet. We're going to do so much graphing in this chapter, you're going to be sick of it. But today we'll take, we'll not graph. We're going to be lazy today. Instead, we're going to just identify if an equation represents a linear function or not, and if it does, can we put it in that form they call standard form. When we have a linear equation, when we have a line on a graph, it has an equation name that goes with it, and that equation name can have several different forms it can be written in. And throughout this chapter, we're going to learn all those different forms that it can be written in, and when they're useful for what. On the test that you guys took, number 6 didn't go so well. It went like this. 3x plus y equals 4. Several of you couldn't get any of the ordered pairs for that because you didn't do anything with that equation. You just tried to work with it the way it was. Others of you remembered or used your notes or something and remembered, oh, you know what, if I put it in function rule form, then it's a lot easier to work with. Is this function rule form right here? No, in fact, according to what you did in your SQ3R, what is 3x plus y equals 4? What form is that? This is standard form. Standard form isn't very friendly for if they give you an x value and you have to find a y value. It's not near as friendly as if we put it in function form. In other words, get the y alone so that we can say, oh, into 4 minus 3x, I'll put my x value and I'll simplify and I'll see what my y value is. Well, some of you did that and then you were successful with some of the points, and then those ones when x was negative, they didn't go so well. I'm going to tell you right now in this chapter, if things didn't go well on this chapter 3 test or other tests because you're not dealing with subtraction and negative numbers very well, what have I told you several times to do if it isn't working for you left as subtraction and dealing with negatives? Anita? Change it to add the opposite and work with it in that form, and you will be more successful. So this is called function rule, but today they want us to practice standard form to help us decide, we're going to have to be able to identify some parts of it. But first of all, we got to decide if an equation is linear. It has to meet these 3 standards. X and y both have to have exponents of what? 1. They have to both be to the first power. If they're not both to the first power, it's already not linear. X and y are not
0.
No, multiplied together. You can't have x times y or y times x. You can't have any multiplying going on between those two. X and y are not multiplied together. They can be added, they can be subtracted, they can't be multiplied. X and y do not appear in denominators is one of them. X and y cannot be, if you have an x and or a y, they cannot be in any denominator. Where else can't they be? In an exponent. They can't be involved up in an exponent. And where else can't they be? Under a radical sign. All of those are a different type of equation, not linear. They are a different type that we'll learn later. Right now, we're trying to identify when is it a linear. When should it give us a straight line on the graph? If it meets all of these standards, then we can say it's linear. And then, if it is linear, then they want us to put it in standard form. What is standard form? What's it look like?
AX plus BX equals C.
Yeah, AX plus BY equals C.
And where A and B are both not 0.
Okay, and A and B, notice it says A and B are both not 0. Because what would happen if they were both 0? What's 0 times x? 0. What's 0 times y? 0. Would the x's and y's be there anymore? No, you got to have at least an x or at least a y. You got to have one or the other for it to be linear, and you can have both of them. You don't have to have both of them, but you have to have at least one of them. But so that A and B can't equal 0. Okay, so sometimes it is useful to have an equation a linear equation in standard form. And we're not going to learn today when that's useful. We're just going to learn how to put it in standard form and identify the parts. So here's what we're going to practice, because I'm not going to make you graph today. You have to decide if an equation is linear. If it is, write it in standard form. Identify A, B, and C. So how do you feel about number 1? Does it meet the standards above for being linear? 5x minus 2y equals negative 3. Are x and y both to the power of 1? Yeah, it's invisible. They are. When you don't see a power there, it's an invisible 1. Okay, so it meets that standard. Are x and y being multiplied times each other? No, y's are being subtracted from x's. Nothing wrong with that. Are either x or y in a denominator? No. Are either x or y in an exponent? Do you know what exponents are? No. Okay. No, they're not up in an exponent. Are either of them under a radical sign? By the way, here's what radical signs look like if you're not sure what that meant. That's a radical sign.
Oh, yeah.
No. Are either of them under a radical sign? No. So is it linear? Yeah, it is linear. It meets all of the standards. Well, if it is linear, then they said put it in standard form.
Looks like it's already in standard form.
Looks like it already is, isn't it? So we could say in standard form, it's already there. We don't have to work any harder than that. And if it is in standard form, it says identify, or once it's in standard form, identify your A, your B, and your C. Remember, it goes like this, AX plus BY equals C. So what's our A value, class? 5. What's our B value, class? Negative 2. Because we would have to change that to add the opposite, and it would be a negative 2. And what's our C value? Negative 3. Now, today you don't have to do anything with those values, but there's going to come a point where those are going to be important things to be able to identify. Anybody have questions on that one? Okay, now let's go on to the second one. How are you feeling about number 2? Do you think it's linear?
No.
No.
Why not?
Because
Go ahead, Audrey, why do you think it's not?
2 is a denominator.
2 is in a denominator. Did it say 2? Did it say a constant can't be in a denominator? What did it say can't be in a denominator? X or Y. Are X or Y in a denominator? No. Okay, so it passes that test.
Looks like it's okay.
Is anybody got another test they don't think it passes? Are X and Y both to the first power? Yeah, they actually are, even though they're not there, remember? If you don't see a power on something, it's to the first power. We already decided, okay, we haven't decided this. Are X and Y being multiplied times each other? No, they're on opposite sides. They're not even close to each other. How about, we already said they're not in a denominator. How about, are either X or Y in an exponent? No, Nita?
I was just wondering, since it's a fraction, would it be in a negative power? Or would that only be decimal?
It's a negative power when it's a number, or it's a decimal when it's a number being taken to a negative power. Okay. So, are X or Y under a radical sign? No. You know what? This is linear, you guys. I'll tell you what might be kind of somewhat confusing you. We could rewrite this like this. 4y equals, does anybody remember what I said back in chapter 1? When there's a variable in the numerator, it can come out beside it. So how can we rewrite x over 2?
1/2 x.
1/2 x plus 5. So see, x and y are being multiplied. They're both to the first power. Even though x is being multiplied by 1/2, that's nothing to do with the power. Okay, is it in standard form then? No. Okay, so what do we have to do? How are we going to get it in standard form? What has to be true? Who has to be together on the same side? X and y. So let's move these x's over there. Say, you know what, the constant wants to be alone. Let it be alone. we can't really take a half an x away from y, so we have to write it like that. 4y minus a half an x. They're not like terms. Equals 5. There's our constant all by itself. There's our c. But we probably still could do a little bit of something to this. What else could we do?
We could add the opposite.
Yeah, we could make it add the opposite, and then the x and the y could trade places, because in addition they can, in subtraction they can. So after we change it to add the opposite, then we can have x's and y's trade places, and bingo, it's in standard form. Now, some math books like the a value to be a whole number, and the b value to be a whole number, and the c value to be a whole number, but I don't think our book did this. So we're just going to go with, if the back of the book wouldn't give this answer, then they decided that's what they wanted, they just didn't, talk about it in the lesson. We're going to just leave it as it is. I'll let you leave it as this. So, what's our a value? Negative 1/2. What's our b value? 4. What's our c value? 5. By multiplying everything by 2, which we can do, whatever you do, if you do it to every piece, you're okay. By multiplying everything by 2, we could have gotten rid of the fraction. And that's what I mean by having whole number A, B, and C. But I don't think this book was fussy about that. So, anybody got questions about that one? Love the next one. Is that linear?
Not yet.
Run it through the test. I didn't ask if it was in standard form. All I'm asking is linear. Run it through the test. Any test that doesn't pass? It is linear, yeah. I pass every test there is. Okay? Is it in standard form? No. In fact, there's a ratio on one side and a ratio on the other. I'm thinking, oh, darn, there's those denominators. But I want you right now to go take your brain back to chapter 1. A ratio set equal to a ratio is a what? Starts with a P. Proportion.
I barely even read use it.
Proportion. And how do we solve proportions? With multiplying
By the
reciprocal.
Oh,
No, not
opposite.
cross
Cross
products. Yeah, cross products. So we could do cross products on this one and we'd get rid of those darn fractions. So we would say, oh, I'm going to take that times that, and that times that. We did this back in chapter 1, eons ago, like so long ago.
Yeah.
So 5 is going to get multiplied. You're going to put the x minus 2 in parentheses. The 5 has to get taken times the whole numerator. And the 3 has to get taken times the other numerator in parentheses. And then you'll do, what's that property called we're going to do next? Distributive property. We're going to distribute. Are we there yet? Is it in standard form yet?
Not yet.
Okay, what do you want to do next? Remember, we need a constant on the right, and we need x's and y's on the left. So there's 2 different moves we can make. It doesn't matter which one we do first.
I'm gonna give you the one.
Nita?
Take 3y away from the
Okay, that's a first move we can make. Take 3y away from both sides. Get the y's over with the x's. Okay, so then we'll have 5x. Take away 3y. Take away 10 equals 3.
And then add 10.
Now we could add 10 to both sides. And we'll have 5x, take away 3y equals 13. Looking pretty good, isn't it?
Yeah, but you gotta change it to add the opposite.
If you when we're identifying the A, B, and C, we have to think of it as the opposite, don't we? So what's our A value? A equals 5. B equals -3. And C equals 13. Okay. So any questions about that one? Any part we kind of lost you, you're like, oh, my brain was kind of rusty back from chapter 1. And moving on to number 4. Is number 4 linear? Need it? Oh, you want to go back to something? No.
For the problem you did on the test, where you're just like showing us what we were doing next, pretty much by saying that.
I guess, kind of, yeah. But I was also, though, showing that this equation really means the same as that equation, how in this chapter we're going to come up with different ways to write the equation. And so this was standard form, though, wasn't it? It was given to you in standard form, which is not as friendly for graphing when you're given some x values. Okay, is 3xy equals 6 linear? Patience? Why not?
Because x and y are equal.
Yeah, this right here, this part right here, we say is not linear. And you have to explain why. You don't get to just say yes or no. Is not linear because x and y are being multiplied. And they can't be. This would create a whole different kind of graph. It wouldn't be a straight line. So if it's not linear, do we do anything else? No. Oh, number 5. Not linear. Oh, why? Oh, wait a minute. Was there something in the rules that said there have to be y's?
It just says x and y's can't be equal to 0.
Says A and B. A and B
Sorry.
can't be equal to 0. A and B can't be equal to 0. Did it say one or the other couldn't?
No.
Can A be equal to 0 if we want it to be?
Yes.
You think? And how about B? Could it be, if B wants to be instead of A, could it be?
Yeah.
Huh. I don't think there's anything in our test that says, oh, if you're missing y's, you don't get to count it. Or if you're missing x's. But if you're missing both of them, our rule says if both A and B are 0, that's not possible. Can't have that. So this is linear, you guys. No y's involved. Who cares? And is it in standard form?
Yes.
Yeah, it really actually is. It's in standard form already. The constant's by itself. The x's are over on the other side. And so if it's in standard form, we're ready to identify A, B, and C. A is 4. B is 0. If you took 0 times the y, then y's would be gone, wouldn't they? So that's why there are any y's, because B is 0. And what's C?
-8.
-8. So, any questions? If you did not understand this objective when you were working in your SP3R, hopefully this will clear some of that up for you. So no concerns?